to not take notes?
All right, guys. For those of you testing, feel free to continue to test. I've got this on video, so I'll make sure I share it with you once I upload it. But for the rest of you, we are continuing on with more derivatives. Okay, we're going to be doing derivatives for a while. We've kind of been doing basic derivatives. And we need to be able to do derivatives of more complicated functions, because some of the functions you'll eventually get to or have to write for some related rates problems, things like that, they're more complicated than just your basic polynomial. Okay? So one of the things that we'll do is we will use the product rule. So that's our learning target. I can use the product rule to find derivatives. Okay? Pretty basic, pretty simple, still the same standard we've been working on. Okay? So the product rule is right here. If you have two functions and they're both differentiable, okay, meaning you can actually take the derivative of those functions, okay? If you have two functions and both are differentiable, then the derivative of those two functions multiplied by one another, that's just notation here, d over dx, okay, represents the derivative with respect to x. Okay, you're differentiating with respect to the variable x, okay? That's all that means. It's just the notation for it that you'll see used, okay? If you're taking the derivative of two functions multiplied together, here is our rule, okay? It's a long rule, okay? There's a proof of it in your books. I'm not going to go through the proof, all right? It's definitely just kind of long and tedious. You can probably look at it sometime, but it's not really that important to you for this class. Okay? Find the derivative of two functions multiplied together. You take the first function and you multiply it by the derivative of the second function. Plus, take the second function times the derivative of the first function. Okay? And honestly, all I remember is that. 1d2 plus 2d1. First function times the derivative of the second, plus the second function times the derivative of the first. 1d2 plus 2d1. D meaning the derivative of. Okay?
He's being a little kid.
Yeah. Alright? So, that was kind of just a little way I had of memorizing the product rule. 1d2 plus 2d1. And that's probably what you'll use too. But the first function times the derivative of the second, plus the second function times the derivative of the first. Alright? So I'll do a couple examples with you. Here's our first one. Okay? Now, could you just FOIL this out and do the derivative how we've been doing it?
Yeah. Yep.
Absolutely, you certainly can. In fact, if I had a choice, I probably would, but I want to show you how the product rule works. For some of these coming up, like this one, alright, that really doesn't work anymore. You have to use the product rule for sure. There's no way around it. Okay? So, for this one, if we're going to do the derivative, the first set of parentheses I would call our first function, or f of x, okay, if you're following the rule. And the second set of parentheses I would call the second function. Okay? So if I'm going to do the 1d2 part, okay, well 1 stays the same, so I'll have x to the fifth plus 2. d2 means the derivative of the second function. The derivative of x cubed minus 6x would be what?
3x squared.
Minus 6. 3x squared minus 6. Okay, good. Okay, so there's our 1d2 part, plus 2 times d1, or the derivative of the first function. What's the derivative of the first function? 5x to the fourth. I will ask you in a problem like this to go ahead and simplify that. That's not too much. There's just a little bit of foiling and distributing, but to combine all your like terms and get your final answer. Okay? This right here is the reason why I probably just would have foiled in the beginning. Okay? But I'm showing you how it works with some easy ones here to start. Okay?
Since addition, could you just take away the parentheses?
You still have multiplying stuff.
Wait,
You still gotta multiply stuff
It's a
together.
FOIL.
Never mind.
Wait, you want us to simplify that further?
Yeah.
That's why you said that we wouldn't
So-
usually do it like this.
Go ahead, ask.
No, it was just gonna be, normally would we do this one, just factor
If I would give you this function on a test and say find the derivative, I would probably expect you guys to FOIL it out and then find the derivative, if you're given a choice, okay? The only reason I'm doing this one to start is to show you how the product rule works with two fairly simple derivatives, okay? But the ones that on the test, I'm pretty certain I just say find the derivative, and you'll have to know, okay, well, can I just FOIL it and then do the derivative? Or am I gonna be stuck having something like this? And then definitely you have to use the product rule. So you'll get to where you know. Okay? So let's get back to the FOILing here. That'd be 6x squared minus 12 be 5x to the 7th minus 30x to the 5th.
We have to put that in then chronological order.
You will, yeah.
Did
So-
Miss Carey not teach you anything? Oh my god.
8x to the 7th minus 36x to the 5th
Plus 6x to the second.
plus 6x to the 2nd minus 12.
interesting. It's very, very interesting. Not how I would have done it,
So then if you foiled just at the beginning, you would have got the same thing.
Yep.
but. Oh, geez.
I'm guessing if you FOILed, you would have had x to the 7th minus 6x to the 6th plus 2x to the 3rd minus 12x.
You said that wasn't right when I did it.
Were you getting it right?
Yeah.
If I just didn't follow your order.
Right.
God.
Respect your smartness.
That's awful.
Okay. Alright. Second one here. At times like. Alright, this one. Some of you probably would be fine, again, distributing that. I would change this to x to the 1/3 and then distribute x to the 1/3 to both terms. Some of you wouldn't like that because there's a fraction in it, okay, but either way, you're gonna use a fraction eventually anyway. Again, if it were me, I would probably have distributed it and then do the derivative. But again, to practice the product rule here, what am I gonna have?
Should we change it? Do x to the 1/3?
Sure.
Okay, x to the 1/3.
X to the 1/3 because the first function stays the same.
Negative 5x to the fourth.
Negative 5x to the 4th. Because the derivative of 4 is 0, the derivative of negative x to the 5th would be negative 5x to the 4th. So there's our 1d2 plus 2. What's the derivative of cube root x?
1/3 x
One.
to the negative 3.
Careful, 1/3 x to the
Negative 2.
negative 2/3. Because 1/3 subtract 1 would be negative 2/3.
It's fine.
So 1/3 x to the negative 2/3.
That's all I can ask for.
They're ugly.
Love them.
Okay?
This stuff is not fun.
I just love it.
That's
The
right.
I
passion.
just love
This
letting
is
them
gonna
go
go
for
for
it.
you.
Negative 5x to the what?
4 and 1/3.
4 and 1/3, but we don't use mixed numbers, so
12 over 3.
Segregate. Do 13
13/3. Yep.
Wait, what are you doing?
You gotta make it common denominator 4 times.
When you multiply, you add exponents, right?
Yeah.
So 1/3 plus 4 would be 4 and 1/3. Correct? Write that as an improper fraction.
3 times?
4 times 3 is 12 plus 1, 13.
I forgot that
13/3.
entire rule.
Okay.
Did Miss Carey
No,
not
it's
teach
like-
you anything?
No, I didn't. I
It's
forgot.
like algebra
Yeah, exactly. That's a long time ago.
Okay. Then back here, you do have to distribute. Take that term times 4. That's pretty easy. What's 1/3 times 4?
I said it too.
4/3.
4/3.
Okay.
What was?
Alright, sorry, maybe I didn't hear you.
That's what Kyle said. I said 4/3. Said 4/3.
So
That's what I
4/3
said too.
x to the negative
And
2/3.
he was like looking like we were crazy.
Yeah, why did you do that?
I didn't know what I heard.
I said 4/3.
Okay. So that was good.
I was so confused.
What did you hear?
Me too. I don't
I didn't know what I heard.
What?
You said 4.
Then taking negative x to the 5th times 1/3 x to the negative 2/3, what do you get?
1/3 x to the 17th over 3. Something like that. Isn't that right?
What?
You
What?
5.
This is a positive 5 plus a negative 2/3.
Yeah. You multiply that out thing.
No, you don't, you add.
It'd be.
Exponents.
We're multiplying
Yeah, you
x
add
right
4 and
now.
1/3, wouldn't it?
Be 4 and 1/3.
How? Because 5 plus negative.
5 plus negative 2/3.
Idiot.
Okay, but you have
Take-
4 and 1/3 up there, and you have 13/3.
Yeah.
It's 5 minus
Okay.
We're not on
2/3.
that right now.
5 minus 2/3.
We are taking
Do you see the minus?
x to the 5th times x to the negative 2/3.
Yeah, leave the x's out of there. Just get the print.
Right?
Exponents. Yeah.
Yeah.
When you multiply, what do you do with
You add 'em.
exponents?
You have them.
What's 5 plus a negative 2/3? 4 and 1/3.
What's 5 minus 2/3?
5 minus 2/3.
Oh, Jesus. All right. Yep. Makes sense.
That'd be x to the 4 and 1/3, or again, x to the 13/3.
I was getting
Close. Hopefully your test.
We do have some like terms.
That would be.
Negative 5 x to the 13/3 minus another 1/3 x to the 13/3.
This fraction's exponent stuff is not.
What is 16/3?
Negative 16/3.
You make me doubt every answer now. Oh my god.
Brother.
What?
Oh my god.
What are
You
you
gotta be
confused
kidding
about?
me.
Fractions,
man.
How are you getting negative 16/3?
Negative 5. Stay out.
It's
Oh, sorry, guys, auto stats, people.
Okay, alright. Please explain this to me.
Okay. Negative 5.
Yeah.
I'll just use x, alright?
Don't use x. Don't use x.
Negative-
Just keep x out of it. You don't need x.
Negative 5 minus 1/3
Yeah.
would be what?
Put it into.
Are you kidding me?
Negative.
Are you kidding? Alright, so then why? Why? Give me this. Give me this. Why are you multiplying that and that for this one?
Because that's how you get.
No!
Subtract
We're
it
not even
first.
multiplying yet.
We're not-
We got negative 15.
Subtract
You have to add it
So it's definitely
first.
right.
You
I'm right.
first.
Yeah, but 5.
I'm still right. Quiet.
What'd
I'm
you
still
say?
right.
Okay.
But
I'm
5
still
here-
right. Quiet. I'm still right.
Fine! Get
As
this
of right now,
over
I'm
with.
still right. Okay. This would be negative 16/3 if I did this.
Correct.
Exactly. Okay. Why? Same thing here. You got 13/3.
Mm-hmm.
And if you do that times that plus that, you get 13/3.
Mm-hmm.
Why? What did you ask? I don't know what you're asking. I don't know what it was. You just proved
The
yourself
x,
wrong.
the
No,
x
what's
to the
one that-
5th. The
That
x
was
to
the
the
What
fifth.
was I prone for?
Fifth
What was-
minus
It's the x to the
2/3.
That,
5th.
okay, so why that times that plus that, why did that work? It did work, never mind. Yep. Yep.
Sometimes it works to just talk things over.
Oh,
Why is that an oh moment?
Because I can go oh when I want to go. Yep.
Okay, anyway, hey, up here.
Yep,
Alright.
Kyle, be quiet.
go. That is fine. That is fine. You don't need to make that a
Oh,
positive
doesn't play.
Yes,
exponent.
it definitely was on that.
Once you get there, though, that's pretty good. Okay. Again, I think it would have been easier to have just distributed it right away, because either way you're working with fractions, and then the derivatives of the two terms would be simple, and you get to this pretty quick. Okay. Now, when you do these, when you do these, you would make 4x squared your first term, cosine x your second term, or your second function. So 1 times the derivative of the second plus 2 times the derivative of the first. They'll both actually, there'll be a lot less simplifying to do in these because you won't be able to do all different trig functions.
That's our homework, just those two,
Okay.
right?
No, your homework.
Oh,
You
dang
can
it.
stop.
Why did you bring up homework?
Uh,